Time value of money. This is one of the most basic concepts for all actuarial exams. The Let us start with simple interest and compound interest. Simple interest. The major difference between the simple interest and the compound interest is that in the case of compound interest, the interest is paid on the interest earned in the previous years. So, for example, an amount of as given in the slides, the it's a simple formula. The An amount of C deposited in an account that pays simple interest at a rate of I% per annum for n years, the deposit will have an accumulated value too. So the interest earned is C into n into I in percentage terms and plus initial principal value of C. Okay, in case of compound interest, interest is earned. We can see the exact differences in the next example given in the next slide. Suppose an amount of 30,000 is deposited in two banks, one paying a simple interest at 10% and the other one paying a simple compound interest at 10%. So in the case of a first bank, we earn 3,000 interest for each year. So after 2 years, the 3,000 plus 3,000 becomes 6,000 and our total accumulated amount will be 36,000. In case of the second bank, in the first year the interest earned is 3,000 and in the second year interest is earned on the principal value as well as the interest also. So the amount earned on principal value is 3,000 and the amount earned on the interest is 300. So the total interest earned in second year is 3,300. Hence the total interest earned in 2 years becomes 6,300 instead of 6,000 in case of simple interest. So that's how the accumulated value for compound interest is derived. So in this graph we can understand the power of compounding, as the simple interest and compound interest may not have a much difference for first few years, like first 3-4 years, but as the number of years goes up, as the accumulated interest value goes up, the compound interest has an enormous power to significantly improve the accumulated value compared to the simple interest. So there are multiple applications of this concept which we will see in the later chapters. So accumulation factor. Accumulation factor is nothing but a single value that can be multiplied with the initial principal value, so that we will know the final accumulated value after n years or after some time from time t1 to t2. So for example, in case of a simple interest, it becomes 1 plus ni, and in case of a compound interest, it becomes 1 plus I whole power n. So this is a simple concept where a new notation is given for the existing formulas. Principles of consistency. So what is principles of consistency? So for example, we have different interest rates. For example, 6% in the first year and 7% in the second year and 8% in the third year. So the interest earned in 3 years will be same as if we calculate the interest earned for first year and then second year and invest the same amount in second year and then invest the same amount in the third year and calculate it separately. So this is a simple concept with a consistency in the values, even though we calculate for n years or we split each year into some smaller parts and continuously invest the same amount. So then it will be the same. Say for example, as shown in our previous example, in the case of compound interest, the interest earned on this, so in case of, we can calculate it with a simple formula 1 plus I whole square into 30,000 or 1 plus 10 by 100 into, say for example, if the second year the interest rate changes to say 11%. So then we have to calculate separately, and even then it will be the same. We will get a 33,000 accumulated value after 1 year, and then we will invest the 33,000 for second year at 11% and we'll get a different value. So these principle of consistency is mainly used when there is a change in the interest rates in multiple time periods. Present value. This NPV, net present value, this is one of the most important concept in finalizing the project outcomes and large scale projects or any investments or any valuation. Say for example, we will we always have some cash flows either from a fixed bond or from a real estate or from some project or from some business. So every time we need to know the present value so that whether it is profitable or to check whether it is profitable or not. So this present value concept is one of the most important thing, and we keep on applying this concept again and again and again in CT2, CT8, anywhere. I mean, this is one of the most building blocks of the actuaries exam. So present value is nothing but, let us say we have some present value which is invested at an interest rate of I. So present value into 1 plus I whole power n becomes accumulates to C. So C is the accumulated value after n years at an interest rate of I. So what is the value of the, then PV becomes C by 1 plus I whole power n. If we define a new as 1 by 1 plus I, then we get the present value as C mu power n. This is the actuarial notation. Mu is given in the actuarial tables. So mu values are given. So we can use for different years. We can use those values directly to calculate this thing. So before going to the discount rate and interest rate, what is meant by discount? Say for example, whenever we go to any shop or market, they will give discount on the original price. Say for example, that let the cost of the product is 100 rupees, they say that they will give discount of 20%, and then we need to we can buy the product at only 80 rupees. So, and whenever we calculate, if we know the discount rate, how do we calculate the accumulated value after 1 year? Discount calculations are done based on, say, 80 rupees we got it by using the 100 into 1 minus 20% or 0.2, which becomes 80 rupees. So similarly, if we want to know the accumulated value at the given discount rate, we have to divide by the, say for example, if we invest 100 rupees today and the current discount rate is some D, and we want to know the accumulated value after 1 year. So we have to divide it by the 1 minus D, because 1 minus D is always less than 1. Only when we divide it by 1 minus D, then only we can get a value, accumulate it, we can get a value higher than the 100 rupees. If we multiply it by 1 minus D, then we will get the discounted price only, which is not we want to calculate. So and in the same way, if it accumulates at an interest rate of I, the value becomes 100 into 1 plus I. So if we take only $1 or £1, so after 1 year, if D is discount rate is given in the question, then 1 by 1 minus D is the accumulated value after $1 after 1 year, or 1 into 1 plus I is the accumulated value. So these two should be ideally equal, and this relation gives some useful results such as nu equal to 1 minus D, because nu is equal to 1 by 1 plus I, and if we calculate the value of D from the 1 by 1 minus D equal to 1 plus I, this relation, then D equal to 1 will get the result D equal to I by 1 plus I and D equal to I nu. This is very important relation, and the main important concept we need to understand, 1 by 1 minus D equal to 1 plus I. So discount rates. So what are the various discount rates? Similar to the interest rates, there are multiple discount rates like simple discount rate and compound discount rate, and relationship between the accumulation and discount factor. So in case of in the case of discount rates, we always calculate from the accumulated value. Suppose an amount C is due after n years, so the value after n years is C, not the value invested in the first year. So the value accumulates to C. So C, and after n years and at a rate of simple discount of D per annum applies, then the sum of money required to be invested now, so which is nothing but the present value of C is C into 1 minus n into D. So in other words, present value by 1 minus ND is equal to C, which gets accumulated to C. In the same way, as similar to the compound discount rate. So present value by 1 minus d whole power n is equal to c. Relationship between accumulation and discount factor. So a of an accumulation factor is nothing but 1 plus I whole power n. Otherwise 1 by 1 minus d whole power n. So these concepts should be clear now. And effective rate of interest and discount. Say for example, we know some value at a period just 1 year before the final period or 1 month before the final time period. So we know the value at n minus 1 time period, and we know the interest rate for the time period n minus 1 to n. Then as per the basic equation of the interest rate, a into accumulated value of n minus 1, the value accumulated up to n minus 1 into 1 plus I is equal to a of n. So which gives the equation in equal to an minus 1 by an minus 1. So there is an example in the material to calculate the in based on the values, accumulation values given at different periods. In the same way, going by the basic concepts, if the value is accumulated to an minus 1 at time period n minus 1, then an minus 1 divided by 1 minus d becomes a of n, which gives the effective discount rate of this much. So I hope the concepts are clear now.